Okay, so I start off with $10,000 and I am splitting them up into two mutual funds. So one of them is Fund A and the other one is Fund B. Now that does not mean that I'm splitting it up in half. So this is not $5,000 and this is not $5,000. That is incorrect, okay? I can invest different amounts of money into different accounts. So I know because I'm adding them together, the amount of money I put in A and the amount of money that I put in B is gonna add up to equal $10,000. And now they have the percentages that I get from each account. So Fund A rises 6% in 1 year. So I make 6%, 0.06 in Fund A every year. The percentage I make back in Fund B is 9%, so that's 0.09B. And the money that I get back from the investments is equal to 684. What I have here is one equation and two equations. That is a systems. So when I graph it, it's gonna look something like this. And I'm gonna look for the point of intersection. So when I do that, I'm going to use Desmos. So I already put it in here. X plus Y equals 10,000 and 6% X times 9% Y equals 684. So when I do that and I graph it like this, I'm looking at my point of intersection right here, which is 7,200 and then 2,800. So I'm gonna write that down. My point of intersection right here is 7,200 and 2,800. Well, I put in my X value as A and I put my Y value in as B. So when it says, how much should I invest in Fund A? Well, that is my X value. My X value is $7,200. So that is how much I put into Fund A. All right, so this is calculator active and I have another systems of equations. So right here, Desmos is going to be your best bet. I put in both of these equations into Desmos already. The first one is y equals x squared plus 2x plus 8. The next one is y equals negative 4x. When I look at my graph, it looks like it's only intersecting one time, but you want to be careful and you want to zoom in. The more I zoom in, I can see that there are two intersection points. Oops. All right here. So the first one is going to be negative 2.8, and the top one up here is negative 4.16. So go back to the question. It says, what is the larger y value? So right here, one of my y values is 16, one of them is 8. The larger one is going to be 16. So my answer is that the larger y value is going to be 16. The ordered pair is technically negative 4.16, but the y value is that one right there. All right, I have a stats problem right here, and whenever I have this word standard deviation, I know that I'm gonna do it on the calculator. So I can put all of this into the stat edit list right here. So I'll put it on my calculator. I hit stat, and then I hit enter for the word edit. Now in my L1 column, I'm gonna put these numbers in. I have 2 zeros, so I'm gonna hit 0, enter, 0, enter. I have 3 ones, so I put 1 in 3 times. I have 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5. I have 3 3s. And then I have 2 4s right here. So 4, 4. All right, to find the standard deviation, it's just a quick calculation. I'm gonna go to stat, calculations, and then because I'm only doing one variable, because I only put it into L1, I'll hit 1, enter, and then my standard deviation is right here where it says sigma x 1.2. So my standard deviation, as simple as that, is going to be 1.2 for this problem. Okay, so I already went ahead and put all of these data points in order. So I have 50, 50, 55, 56s right here, 2 58s, 59, 60, 62, 63, and 70. So make sure you have 12 points if it says there are 12 data points. Now a student who is 6 feet 8 inches. So I have 6 feet 8 inches. I gotta convert that into these units. So this is gonna be 6 times 12 plus 8. So someone who is 6 foot 8 inches is 80 inches tall. I'm gonna add that data point right at the end, 80. because that is my highest value. So I'm looking at the mean and the median. So obviously if I add a number that is much higher, the mean is gonna go up. So that's just obvious. If I add a number that's much higher than the rest of the data points, the mean is gonna go up. But let's see if that changes the median. So without this 80, let's pretend it's not there. I would just go until I hit the center. So get rid of these two. Sorry, so you would get rid of these two, and then 50 and 63, 55, 62, 56, 60, 56, 59, and I'm left with 2 in the center, 58, 58. So the median would be 58. So I'll write that down. 58 without the 80. And then if I have the 80 here, let's include it. 50, 80, 50, 70, 55, 63, 56, 62, 56, 60, 58, 59. It's actually still going to be a median of 58 if I have this data point. So the median is gonna stay the same. So which one is that gonna be? The mean changes, but the median does not. That's gonna be the answer right there. Okay, this is just a solving equations problem. So let's begin by distributing. 2x plus 16, I drop down my negative 4x. And on the opposite side, I have 10x plus 4. I want to get the x's on one side, so let's combine like terms to begin. 2x and negative 4x, so 2 minus 4 is negative 2x. And then I'll bring down my plus 16, 10x, and plus 4. I want to move this x over here because that'll keep it positive. So add 2x to both sides. At the same time, I can subtract 4 to get the constants on one side. These cancel, leaving 12x. And on this side, I have 12. I divide by 12. Sorry, this is just 12 here. Divide by 12, leaving x equals 12 divided by 12 is 1. So x equals 1 will be my final answer. Okay, 2 ways to do this. Either way, it's going to be a systems problem, so I have to figure out what the 2 equations are. I have a total of 120 coins, and I know they are quarters and dimes. So quarters plus dimes will give me 120 coins. Total of $27. So I know quarters are worth $0.25, so 0.25Q, plus 0.1 for dimes, because they're 10 cents, will give me 27. So first method is to plug it into Desmos. I'll make my Q equal X and my D equal Y. So I'll plug these two in. Q will be X, D will be Y. Okay, so I have that right here. X plus Y equals 120, and then 25 cents, X plus 10 cents, Y equals $27. Right here, I have my point of intersection, which I see right here is 120. So 100 is X. X is quarters. So I have 100 quarters, and then 20 is dimes. I have 20 dimes. So that is the easiest way to do it. How many quarters does she have? She has 100 quarters, and she has 20 dimes. Okay, method 2, because I think it's really important to do this by hand, I can solve by elimination. So the Q's line up, the D's line up, and the constants line up. If this is 1Q and this is 1D, I can eliminate this one by multiplying this by -4, because -4 times 0.25 will give -1. So let's do that. If I multiply -4 times 0.25Q, that'll give -1Q. On this side, -4 times 0.1 will be -0.4D. And then 27 times -4 will be -108. And now I can drop down my other equation. Right here I have 1Q plus 1D equals 120, and now I can eliminate. So when I solve these, this is the purpose of eliminating the Q's. 1 minus 0.4 is going to give me 0.6D, and then 120 minus 108 is going to give me +12. To get D by itself, let's divide by 0.6, eliminating the 0.6 and getting the dimes by itself. 12 divided by 0.6 is 20. So my D value is 20, which I have up here. I can confirm. And then I go back to the easier equation. My easier equation is right here. Q plus D equals 120, so I can plug that in. Q plus 20 for D equals 120, and that leaves my Q value being 100, which again, I can confirm she has 100 quarters. Okay, in this problem, we are comparing high school GPA, which is going to be my X value, independent, affecting how many games missed, which is going to be my dependent Y value. All right, number one, what is the correlation coefficient and what does it mean? On your calculator, make sure you hit second catalog. It's going to bring you to this list, and you want to make sure your diagnostic is on. So go all the way down. All right, diagnostic on, hit enter, enter, and then it's done. All right, and then I'm going to go stat, enter, to get to my stats list, and that's when I'm going to put in my X values that I have. So 2.3, 2.4, 4.0, 2.2, 3.6, 3.4, 3.8. I'm going to go over to my Y values, 12, 13, 0, 15, 3, 2, 1, and then they line up, so I have all my points. All right, I want to find the correlation coefficient, so my calculation, stat, calc, 4. That's going to give me pretty much everything I need to know right now. Okay, so this is what I have. Let's write my linear equation. My A value, negative 8.2, because I have that right here. I add an X to the end, and then my B value is plus 32. My correlation coefficient, that is represented by the variable R, and right here I have a negative 0.98. So R equals negative 0.98. It is on a scale of negative 1.0, in the middle 0, and then positive 1.0. So this means strong, positive. This side means strong, negative. So a negative 0.98 is going to mean that there is a strong negative correlation. The easiest way for you to envision what slope means is that you know it's going to be rise, which is y, over run, which is x. So if my y is my games missed, I know that games missed is going to be my y value, and that my x value right here is GPA. Okay, so let's take a look at what the m value actually is. M is negative 8.2, which I can envision as negative 8.2 over 1. So now it's easier for me to interpret what the slope means. If I miss 8.2 games, my GPA is going to go down by 1. So this unit is games, and this one is GPA. So if I wanted to sum this up, I could say for every 1.0 decrease, because it is negative right here, in GPA, you miss 8.2 more games. When I'm looking at the y-intercept on a graph, that would be somewhere right here where x equals 0. So the y-intercept is my b value, and I know from my equation up here that's going to be the number 32. So my b value is 32. If I know that x equals 0, what does that mean? Well, my x value being 0 means that my high school GPA would be 0. And if my high school GPA is 0, my y-intercept is 32 games. Now, what does this mean? If I have a 0 GPA, that means I miss 32 games. So that is basically the answer. If you have a 0 GPA, you miss 32 games. In this problem, we're looking at the first player at the projected versus the actual. So my equation for this problem was y equals negative 8.2x plus 32. So for the first player, he has a high school GPA and x value of 2.3. So I'm going to plug that back in here. So my equation would be negative 8.2 times 2.3 3 plus 32. So my actual, sorry, this is my projected. If he has a GPA of 2.3, he is projected to miss how many games? So let's plug this in. Negative 8.2 times 2.3 plus 32. He's projected to miss 13.14 games. All right, let's figure out what the actual is. The actual games that he missed was only 12. So what is the difference between the projected 13 games and the actual 12 games? All I need to do is 13 minus 12, and the difference is 1. If you wanted to do it differently on the calculator, this is what we would call the residual. So if I go back to my table, stat, enter, if I go to my L3 column, I can put in my residuals. I do that by hitting second stat, which brings me to list, and then my residual is 7. When I hit enter, all the residuals populate, and I can see that it's -1, so that means his projected was 1 higher than his actual, so 1 here and 1 here would give us the same answer. Okay, one more time for the residuals, I can populate that into my L3 column. I go up to L3, I hit second stat to bring me to my list. I hit 7 for a residual, enter, and all these numbers populate. So what is the biggest outlier? I'm looking for the biggest absolute value right here. So I go down, I have a 1, that's pretty large. Keep on going. But right here I have a 2. So that's gonna be my largest number out of all of that. So -2 difference for my residual is the player with a 3.4 GPA. So my biggest outlier is going to be 3.4, and then with that, the Y value is 2. To find any type of projection, I'm going to use the linear equation that I have. My X value is going to be 1.5, and I'm going to drop down everything else from my equation. And when I do that on my calculator, I can figure out the projected scores. Let's do that real quick. -8.2 times 1.5 plus 32. That's going to give me an answer of 19.7. So 19.7 is the projected number of games that he's going to miss. Actually, let's round that to a whole number. It's going to be around 20 games. Okay, right here I have a table, so let's begin with that. How much are these increasing by? Well, each of these is increasing by +1, +1, +1. You can tell between these 2 points, it cannot be a plus because they are going from 10 to 20, 40, 80. We know it's going to be multiplying by 2, which already tells us that this right here is an exponential function. Okay, so if it's looking for the y-intercepts, that means x is going to equal 0. If x equals 0, how do I go backwards from times 2? I'm going to divide by 2. So 80, 40, 20, 10, and then half of 10 is 5. So my y-intercept right here for the table is going to be 5. For this one right here, I can tell that I can FOIL this, which tells me it is a quadratic function. Let's FOIL this real quick. X times x is x squared. X times 2x is 2x, -5x, and then I have -10. If I simplify this, x squared, 2x minus 5 is -3x, and then I have -10. For a quadratic, our constant is going to be our y-intercept. So what is the distance? Well, the distance between 5 and -10, if I were to imagine it on a graph, I have, let's say 5 is right here. Let's say -10 is over here. The difference between them is going to be 15, and it doesn't matter if it's positive or negative. I have a percentage here, 3% annual, so this is going to be an exponential function, which I know is in the form y equals a b to the power of x, where a is my principal, b is my rate, and x is time. So that's really simple if you remember that. I begin with y equals, my principal current population is 700,000. the rate at which is decreasing, so if it doesn't do anything, it's at 100%. If it's decreasing, I'm minus 3%, which means that it is staying at a 97% rate. So if I convert that, it'll be 0.97. And then over time, T years, I could put a T right here. Which one matches that? Well, it's not these two. And the trick is, the common mistake between A and D is that we're looking at here. This means growth if it is over 1, and this is decay. This is decreasing, so I know it needs to be letter D. Okay, so I need to set up 2 equations. I have Sprint and Verizon. So Sprint on this side, Verizon on this side. Sprint is $20 a month plus 5 cents a minute. Verizon is no fees but 10 cents per minute. So let's do Verizon. 10 cents per minute, and Sprint is 20 plus 5 cents a minute. Set them equal to each other. If I solve this, I can subtract 5 cents from both sides. Canceling this, leaving 20. This is 0.05x. And then my last step, to get x by itself, divide by 0.05. When I do that, 20 divided by 0.05 is 400. So my x value would be 400. But I'm not done yet, because the question says, what is the maximum amount of minutes she could use per month and still have a better deal with Verizon? So at 400, they're the same deal, but if I do one less, $3.99, the deal with Verizon would still be better. Another way that you could do it is I could plug in these 2 equations that I have, 20 plus 0.05x and 0.10x. I could plug it into Desmos. So the top one right here, that would be Sprint, and this one would be Verizon. I could take a look at the system of equations, and right here I have 440, so that matches. The bottom line is Sprint, so right before it would be $3.99, which would be why Verizon at $3.99 would be the best deal. All right, in a sequence, my 8th term would make n equal 8, so a of 8 would be 2 to the power of 8 minus 1 minus 20. This would be 2, so this would be 2 to the power of 7 minus 20, and then I can just put this in my calculator. 2 to the power of 7 minus 20 gives me 108. So A of 8 would be 108 as your final answer. Okay, so Xavier has $100 in mutual fund A. So A will give him 10 per year. I can tell that that is going to be linear. So he begins with 100 and he adds 10 per year. That's going to be the 100 plus 10x. Mutual fund B is a percentage back, so I can tell that that's going to be exponential. So I begin with 100. My rate is an increase because it's return. So 1 point, and then it's 5%, so it'll be 0.5. And then my x value is going to be time. So what is my x value going to be? 10 years. So all I need to do is plug in 10 as x. So this becomes 100 times 10 times 10. And this one becomes 100 times 1.05 to the power of 10. Let's plug that in. Okay, 100 plus 10 times 10 is going to give me 200. So mutual fund A is going to be 200 in return, and then mutual fund B is going to be 100 times 1.05 to the power of 10. That's going to be a return of 162.88. Let's round that to 163. So read the question. How much money would he have made? Will he have if he makes the right decision than if he made the wrong decision? So that would be subtraction. How much more? And the difference between 200 and 163 is going to be 37. So that's one way to do it. Another way to do it is if I have these 2 equations, I can plug them in into my y equals section. So mutual fund A is 100 plus 10x, B is 100 times 1.05 to the power of x. If I hit second graph to get to my table, I can go down to all the years and figure out when it switches. So I go down to 10. At 10 for mutual fund A, I have 200, just like I have here, and for B, I have 163. From there, I can find the difference. Like I said, the difference between those two numbers is going to be $37. Okay, to find the average, I'm going to put all these numbers, the sum of them on the top, and then divide them by the number there are. So he needs to take a total of 6 exams. I'm going to divide by 6 at the end. And what does he want to get as an average? 80%. So he's already taken 4, 72, 78, 82, and 64. Those are the 4 exams he's taken. But like I said, this is only 1, 2, 3, 4 numbers. He needs to get to 6. So he's missing 2 more. This one and this one. But we're looking for the average. So these we're going to say are going to be the same. This is the equivalence right here of 2x. When I solve this now I can figure out how to get x by itself. So let's see. If I add up all these numbers, I have 72 plus 78 plus 82 plus 64. That gives me 296. I put 296 plus 2x over 6 equals 80. To get rid of this divided by 6, I'm going to multiply each side by 6. These cancel, and that leaves 296 plus 2x, and 80 times 6 is going to be 480. Really simple from here. Subtract 296 from both sides. These cancel, leaving 2x. 480 minus 296 is going to be 184. Last step is to divide by 2, leaving x as 92. So he needs a 92 average on his last 2 tests. If I go back in and I put 92 here and 92 here, you will see if I add up all of these numbers and divide by 6, I'll get an average of 80. So I went ahead and plotted these points 0, 0, 0, 8, and 6, 0. You can do it on graph paper if you need to visualize it. So I have that right here. If I connect these points, I have a right triangle. So now I have to figure out what the lengths of all the sides are going to be in order to find the perimeter. So up and down, I go from 0, 0 to 0, 8. So I can count them right here. It's going to be 8. On the bottom, I go from 0 to 6. My other leg is going to be 6. And this side, I do not know. This is the hypotenuse. So if I want to label this is going to be a leg A, a leg here B, and I'm solving for C. So like I said, my A value is 8, my B value is 6, and I'm solving for C. So A is 6, sorry, A is 8, B is 6, and I do not know what C is. I'm just going to plug this into Pythagorean theorem. So A squared plus B squared equals C squared. 8 squared, 64. 6 squared is 36, and I'm solving for C. These add up to equal 100. I bring down my C squared. In order to undo the square, I'm going to take the square root, and my C value is going to be 10. Don't forget, it's asking for perimeter, which means I need to add up all these numbers. So 8 plus 6 plus 10, that's going to give me a perimeter of 24. All right, anytime I have a table like this, I'm going to plug this into my calculator. So for my L1, I have the shoe size, and for my L2, I have the age. When I'm trying to figure out what is 1 year different than the predicted, so I'm doing predicted versus actual, which means I'm going to look for the residual. So to find the residual on the calculator, it's quite simple. I go back over to L3, I hit second stat, and I hit 7 for residual. When I populate that here, I'm looking for things that are over 1. So right here, that top one is over 1. Anything else? For number 7, it is over 1. Going down, I don't see right here. Number 8 is over 1. and everything else is under 1. So 3 out of the, how many? 1, 2, 3, 4, 5, 6, 7. 3 out of the 7 are more than 1 year different than the age predicted by the line of best fit. So what percentage is that? I'm just gonna do on my calculator, 3 divided by 7, and I get approximately 43%. That's gonna be your final answer. Okay, so when I talk about these words peak and spread, if I'm looking at a bell curve, this right here would be my peak, how high it goes, and this right here would be my spread. So we're looking at the side, we're looking at standard deviation means spread, and peak means your mean. So I'm gonna plug this in. So I have 15, 35, 18, 30, 25, 21, 32, and 16. When I plug all these numbers in to find the mean and standard deviation, I'm gonna hit stat, calc, and then 1. When I hit 1, I can see that my mean is gonna be 24. So for my original data points, my mean is gonna be 24, and then my standard deviation right here is gonna be 7.17, 7.2. But then it says, I'm gonna add some data points, 24, 22, 27, and 28 to my data. So let's go back to my list. And at the bottom, I'm gonna add those points. So 22, 24, 27, and 28. I go back to stat, calc, and 1, and now I'm gonna find out my new mean and my new standard deviation. So with these 4 points right here, my mean changes to 24.7, and then my standard deviation turns into 6.1. So how did that change everything? Well, my mean, or my peak, it went up. So my peak went up, and then my spread, how far it goes, it went from 7.2 to 6.1. So my spread, or my standard deviation, went down. So let's see, a higher peak and a smaller spread, that would be letter C. Okay, so function 2 is on the graph. This is number 2, and then if I wanted to plot number 1, 2, 0, and then -4, -3, -4, -3 right here, I can figure out how they are going across. So it goes up how many? 1, 2, 3, and across how many? 1, 2, 3, 4, 5, 6. So if it's 3 over 6, my slope is going to be 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2. So I can connect my line just like that. The question is, what is the difference between the y-intercepts? My y-intercept for function 2 is +2. My y-intercept for function number 1 is -1. So what is the difference between that? 2 minus -1, the difference is going to be 3. Okay, so it's asking to find an equation for C in terms of E and M. So if I'm starting with E equals mc squared, this is the one that I'm trying to get by itself. So in order to do that, my first step, because this is m times c, I'm gonna divide by m on both sides. These cancel out, and then I bring down the c squared on this side. I have e divided by m on this side. My final step to get c by itself is to undo the square, which is to take the square root. The square root cancels with the square, leaving c. And on the other side, I have the square root of e divided by m as my final answer. Right here, I'm going to set up a linear equation. It is the cost, so let's use c for cost, is $2 plus 50 cents per mile. Per means x. How much does it cost to take 20 miles? So that would be x equals 20. And all I have to do is plug in my x value as 20. When I solve that on my calculator, 0.5 times 20 is 10, plus 2 is c, and 2 plus 10 is 12, so the cost would be $12 in total. This right here is in the form of a quadratic function. Right here is my a value, which is a negative 16. My b value is 8.4, and my c value is 22. Negative 16 is always going to be my gravity. And we know on a gravity graph, because it's negative, it's going to go open downwards like this. My b value is 8.4. So 8.4 is going to be the initial velocity, which can also be speed. And then lastly, I have my constant. So let's see, Trinity is jumping from a cliff. 22 is going to be that constant, and that's going to be her initial starting point or height. Okay, so in this problem we are looking at slope, and the slope value here is negative 0.0018. So that's saying as the altitude goes up, the boiling point of water is going down. So right here I have 1,000 feet, 1,000 feet, 1,000 feet, 1,000 feet. It's looking for a conversion. So if it's 1,000 feet per 1 foot, how many feet is it going to take to move this decimal place to 1,000? So 1,000 is 1, 2, 3 zeros. I move it 1, 2, 3 times. So this new number would be 1.8, negative 1.8 for every 1,000 feet. So which one is decreasing? Well, I have decreasing here, and I have decreasing here, so I can get rid of A and B. And then lastly, I have 1.8 versus 18. Well, I know 1.8 matches this, so it's going to be letter D. Okay, so this is going to be a vocab problem. A store can buy up to. Up to means that it can buy anything less than. So I can get rid of anything that isn't less than 500. Since this is more than, I can get rid of letter B. So next, the store wants to buy at least. At least means more than. And that's more than shirts than pants. So because pants is larger here, I can get rid of this, leaving C as my option. Let's make sure that this last one matches as well. The store wants to buy at least 100 pants each month. That is at least 100 pants each month. So the word half-life means that it's multiplying by 1/2 or dividing by 2 each time. I begin with a half-life of 30 minutes. I want to see how many times 30 minutes goes into 2 hours. So it begins with 250 grams. I divide it by 2 because that is 30 minutes. And after that, I have 250 divided by 2. So after 30 minutes, it has 125. I divide it by 2 again, and at that point, it has been 1 hour. So that is 62.5. For 1.5 hours, which is another 30-minute interval, divide by 2 again, I have 31.25. And to get to 2 hours, I'm going to divide by half one more time. 31.25 divided by 2 is 15.625. So that should be your final answer. Another way that you can think about it is to write a formula. So this is going to be exponential. Y equals AB to the power of X. So I begin with Y equals, my principal is 250. My rate is 0.5 because it's being divided by half. And then 30 minutes goes into 2 hours 4 times. So if I do that on my calculator, 250 times 0.5 to the power of 4, I also get 15.625. Okay, so this is going to be a distributive problem. I'm multiplying length times width, and my length is 4x squared minus 2x plus 8. That is my length. I'm multiplying it by my width, which is x squared plus 3x minus 2. And now all I'm going to do is distribute all of these to all 3 of the terms in the second trinomial. So 4x times x squared is going to be 4x to the 4th. 4x squared times 3x is 12x to the 3rd. And the last one is negative 8x squared. I do the same thing here. There are 3 terms in the second trinomial. This becomes negative 2x to the 3rd, and then negative 6x squared, and the last one is positive 4x. My last term that I'm going to do is 8. 8 to x squared, 8 to 3x, and 8 to negative 2. That becomes positive 8x squared, 24x, and then negative 16. My last step is to combine all the like terms. So let's begin with the highest one. The highest one right here is 4x to the fourth. My next one, let's do to the third, 12x to the third, and negative 2x to the third becomes positive 10x to the third. My next one after that, the squares, negative 8, negative 6, and positive 8. So these two will cancel, leaving the negative 6x squared. I move on to my single term x's. 4x plus 24x is positive 28x, and then my constant I drop down at the end. So this right here should be your final answer. When I'm multiplying exponents, I can just take the exponents, and when I multiply them, I add them together. So the x's become 2 plus 6, which I know is 8 to the 8th power. Right here, I can just multiply these terms. 2 times 8 is 16, so my numerator is going to be 16, 8 to the 8th. On the bottom, I have 4x to the 6, and again, I can apply multiplication rules. Right here, I do x, 8 minus 6, so the exponent becomes x to the power of 2, and for these terms, I just keep regular division. 16 divided by 4 is 4. Your final answer is 4x to the second. Okay, so anytime I have a stats table like this, I'm going to put it into my L1, L2 column by hitting stat edit. Once I have all that, I'm going to look for the line of best fit. So I'm going to hit stat, go over to calc, and then I'm going to hit 4. Enter, 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 enter. And then my line of best fit, I'm going to write this down. Y equals, my M value is 5.2. X, and then my B value is 76.5. So that's my line of best fit. All I need to do now is what is the predicted score for someone who scored, who studied for 3.5 hours? Well, that makes 3.5 hours my X value, which I will plug in right here. And on my calculator, let's do this real quick. 5.2 times 3.5 plus 76.5. The predicted score is going to be 94.7. Okay, so I'm looking at Amanda and Patrick. So right here, Patrick and Amanda. They both studied for 3.5 hours. I'm looking for who is closest to the prediction. That means I'm looking at the residual, because based on the graph, I'm trying to figure out how far their predicted points are from the line. So when I do that on my table, I'll go up to L3, and then I'll hit second stat. To get to the list, I'll hit 7 for residual, hit enter, and then because Amanda and Patrick both studied for 3.5 hours, I'm looking for the two 3.5s right here. Patrick is the top, he has 0.32, so 0.32, and then Amanda is right underneath it, she has negative 1.7. So negative 1.7. Who is closer to the line of best fit? Well, because the absolute value is closer for Patrick, Patrick is closer. And then in regards to the question, did he overperform or underperform? Because it's a positive 0.32, that means he's over the line. So he overperformed.